Hello. In this session we consider Lorentz force, that when a charge is moving through both electric and magnetic fields, Lorentz found that the charge experiences a kind of force F, which is given by Q into E plus V cross B. This is the formula we got through experiments conducted. That F equal to Q into E plus V cross B. That means there comes two types of forces. One is Q into E, another Q into V cross B. And this part we already found in electrostatics, and we call this as electric Lorentz force. Then this part we can take it as magnetic Lorentz force. So the charge experiences a force in the magnetic field that is given by Q into V cross B. This equation is called magnetic Lorentz force. So when a charge is moving through a magnetic field, it experiences a force of this kind. So if the particle to experience a magnetic force, then the particle must be charged, that Q should not be 0, then V should not be 0. That means if the particle, charged particle is at rest, magnetic Lorentz force will be 0. Then, being a cross product here, V and B will not be parallel or anti-parallel to each other. That means B should not be parallel to B, or B should not be anti-parallel to B. Now these are the conditions required for a charged particle to experience a force in the magnetic field. Okay? Now, from the equation, we can find that the magnetic Lorentz force, direction of the force will be decided by the cross product of V and B. By definition, if it is V cross B, then the resulting vector must be perpendicular to the plane containing V and B. Okay? So, magnetic Lorentz force, the direction can be found out using a very simple rule called Fleming's left hand rule. That if you hold the three fingers of the left hand, middle finger, forefinger and the thumb in mutually perpendicular directions, where forefinger represents the magnetic field, middle finger represents the direction in which the positive charge moves, then thumb will be pointing the direction of the force acting on it. Once again, forefinger the magnetic field, middle finger the direction in which the positive charge moves, then the thumb will be pointing in the direction of the force acting on it. Okay? So this is the method to find the direction of the force. But this method is not always possible to find the direction of the force, because you won't be able to hold your fingers according to the direction of the field and all. Therefore, you can depend on the unit vectors multiplication to find the direction of the force. Okay? So, magnetic Lorentz force, condition for the force to act, and to find the direction of the force, Fleming's left hand rule. So these are very, very important. Based on this, our discussions will be followed. Okay?